Hello students, very good morning. So we are in the session 8 of work, energy and power topic. So we are discussing about the applications of the work energy theorem. Okay. So today's session, right, we'll discuss about the problems relating to the spring. Okay. So generally, when we talk about the spring, right, in our discussion, spring will be always massless. Okay, so the mass irkadu. So even when we say spring is moved, spring is compressed, expanded, spring will not have kinetic energy or gravitational potential energy. ஏன்னா நம்ம எடுத்த concept la what is the spring taken as massless. அதனால even when you say that spring is expanded, compressed, okay, mass irukadu. So kinetic energy term that will not be applicable for the spring. And the madri in some cases spring will be moving up or coming down the madri irukum. Adina appadida there will be no discussion about the gravitational potential energy of the spring. Inga enna varum verum the spring potential energy. Spring potential energy is what? If you have a spring natural length la irundha the spring will not have any potential energy. Adoda spring potential energy ola zero. அப்படி இல்லாம if it is expanded or compressed by a value x னு வெச்சுக்கோங்க, then the spring potential energy in that will be what? Half k times x square. K means what? The spring oda stiffness constant and சொல்லலாம் or the spring constant itself. Okay va? So this is the basic understanding about the spring. We'll start with some very basic questions. This is about comparing the energy of two springs. Two springs A and B having spring constant Ka and Kb. Ka oda value is 2 times Kb. Okay, are stretched by applying a force of equal magnitude. They are stretched by applying a force of equal magnitude. Okay va? If the energy stored in the spring A is A, then energy stored in the spring B will be how much? இப்போ பாருங்க, A இருக்கா B இருக்கா, இதோட ஸ்டிஃப்னஸ் கான்ஸ்டன்ட் எவ்வளோ? Ka. இது என்னது? Kb. அதுக்கிட்ட நமக்கு ரிலேஷன் இருக்கு. வாட் இஸ் இட்? Ka is equal to 2 times of Kb. ஓகேவா? அப்புறம் they both are stretched by applying the same force, means force applied here is F, force applied here is F. பாருங்க, when you have a spring, right, we apply a force to stretch the spring. Spring will be expanded. So let us say x is the expansion. The applied force will be balanced by, when you are expanding it, the applied force will be balanced by the restoring force. Okay, so this x, right, will be representing what? The amount of elongation. So paranga, what is the relation between them? F is equal to kx. Tomorrow force F apply panna, what is the expansion here? X, right? So what is the relation between them? F is equal to what? Kx. So paranga, the x value will be what? F by k, which means here the expansion it will be F by k varum. It will be F by Kb, because both the places force is same. They're asking what is the ratio of the energy stored. Calculate ratio of the energy stored. What is the energy stored in the spring formula? Half kx square, right? So Ea oda value enna varum? Ea is equal to what? Half Ka into adoda expansion or elongation square. Elongation F by Ka, right? So F by Ka the square is the Ea oda value. So paranga, half Ka into F square by Ka square. Okay, so what is it coming as? Half F square by Ka is the Ea oda value. Apro Eb paranga, Eb will be what? half into kb into இங்க எவ்வளவு expansion f by kb the square. இங்க similar term தான் வரும். What is it? Half into f square by kb வரும். So we are required to find eb, energy stored in that spring b in terms of ea. Okay, அதுக்கு என்ன தெரியுமா? Let us divide both of them. So eb by ea பண்ணுங்க. eb by ea பண்ண என்ன வரும் பாருங்க. So eb means what? Half f square by kb divided by ea எவ்வளவு? half f square by ka. half f square cancel ஆயிடும். ka numeratorல போயிடும். So ka by kb இது என்னது? ka by kb. So ka is what? 2 kb, right? Substitute பண்ணுங்க. So eb by e oda value எவ்வளவு வருது? It is coming as 2, which means eb is equal to what? 2 times of ea. Check பண்ணுங்க. Are you getting the same answer? What should be the value? இதுல என்ன இருக்கு? What is the procedure? தனித்தனியா they are giving information about both the springs, right? Spring A பத்தி சொல்றாங்க, spring B பத்தி சொல்றாங்க. What is the information? அதோட spring constants நடுவுல we are having a relation. What is it? K ஓட value is equal to 2 times of kb. அதுக்கப்புறம் they said both of them are expanded by the same force. ஒரே force வச்சு நம்ம expand பண்ணா what is the amount? இப்போ நம்ம ஒரு f force வச்சு நம்ம ஒரு spring expand பண்ணா the corresponding elongation will be what? F is equal to k into x. அதுல இருந்து அந்த expansion வரும். So the expansion value x is equal to what? F by k. The expansion value will be equal to what? F by k. Okay va? So அதுக்கப்புறம் we are looking at what is the relation in terms of their spring energies. So what is the answer? EB should be equal to what? 2 times of EA. Okay. பாருங்க அடுத்த concept. This is a problem where we are expanding the spring and then expanding again. Okay. So this is a important model of question. ஏன்னா நீட்ல இந்த மாதிரி questions வரதுக்கு there will be lot of scope. So ரொம்ப complicated ஆன systems கொடுத்துட்டு அந்த மாதிரி questions at least in the recent NEET papersல வரது கிடையாது. Recently what we are getting off late இந்த மாதிரி straight கொஞ்சம் trickyயான situations or straight formula based questions தான் maximum வருது. So அதனால we need to look at these kind of questions. Even the previous question also, ratio of the spring energies, they will give some relation between spring 1 and spring 2. Other than that, they will be asking what, like in the முன்னாடி நம்ம பார்த்த question they are asking us what is the ratio of the kinetic energy, the spring energies. அந்த மாதிரி questions வரதுக்கு there will be lot of scope, at least based on the recent year oda trend base பண்ணி we will be able to look at these kind of questions as the important ones. பாருங்க, a spring force of constant 800 Newton per meter. So அதோட spring constant எவ்வளவு? 800 Newton per meter. Has an extension of 5 cm. Already அதுக்குள்ள extension இருக்கா? The spring என்னது already extended. எவ்வளவு? 5 centimeter from the natural length la irundhu. Okay va? The work done in extending it from 5 centimeter la irundhu 15 centimeter. So already 5 centimeter extended. Angala enna pannanom? We should extend it so that finally what is the extension of the value? 15 centimeter. Eppadi approach pandrathu parunga. When it is initially having extension, idhilende we can calculate what is the initial spring potential energy. Eppadi calculate pandrathu? Half into 800 into x square idana, which is what? 5 centimeters. Inga parunga, idu eppadi iruka? Centimeters iruka. So we have to 5 centimeter means what? 5 by 100 meters, which means what? 1 by 20 meter. 5 by 100 anna evladi? 1 by 20 dana. So 1 by 20 square. Parunga, idanadi 2 ones are 2, 400s are 400 into 1 by 20 square means what? Adu 400 dana. Cancel aidum. So initial potential energy evla? 1 joule. Initial potential energy evla? 1 joule. Okay va? Now we need to find out what the final potential energy. Final potential energy evla varum? Half into k, adana 800 dana, into x square. So final situation la what is the extension? 15 centimeters. 15 centimeter means 15 by 100. Idanadi 3 by 20. So parunga, 3 by 20 the square varum. Ipo enna achidi? 2 ones are 2, 400s are inge opadudha 400 into 9 by 400 varum. So this is what? 9 joules. So on the spring coil irukra initial potential energy evla? 1 joule. Angalende nama திருப்பி expand பண்ணா spring potential energy value will be increasing, right? So initial potential energy evla? 1 joule. Angalende we are extending it so that the final spring potential energy is becoming what? The final spring potential energy is becoming what? 9 joules. Ipo parunga, what is the work energy theorem concept? Here we are applying the work energy theorem only on that spring. So work done by the external forces is equal to what? The spring case la veru on the spring mattum neenga observe panna kinetic energy concept varadu. Ena already nama sollirukom. What is it? For a spring we will assume it to be massless. So the work done in extending the spring will be always what? Change in potential energy term mattum. So what is it? Final potential energy minus initial potential energy dana. So 9 joules minus 1 joule evladi? 8 joules. So this is the work that we are doing to extend the spring from 5 centimeter landu up to 15 centimeter. Okay va? So what is the answer for this? Option B. Munadi question enna? What is the answer for this one? Option A. B will be equal to what? 2A. Okay va? So we will go to the next question. Look at this one. An object mass m is attached to a vertical spring. Eppadi we are attaching it to a vertical spring and the spring oda constant k, and is allowed to fall under the gravitational force. Means nama the object is attached to vertical spring, right? Release panna udane what is going to happen? The mass will start coming down, and because the mass is experiencing the gravitation force, adanal the mass will start coming down. What is the distance traversed by the object before being stopped? Stop agaradu munadi what is the total distance that is covered by the object? Okay va? Inga parunga what is going to happen? This is something which we will discuss again in enga theriyuma oscillations liyu nama indha patti discuss panna porom. We will discuss about the same kind of situation in the oscillation chapter also. Inga parunga, if you look at releasing an object by tying to a vertical spring, இப்படி தான் வரும் motion கிட்டத்தட்ட. So we are releasing, மேல இருந்து we are releasing வெச்சுக்கோங்க. So this ball will start going down and என்ன தெரியுமா? This is going to perform oscillations. That's why we will discuss about this in the oscillation chapter also. எப்படி what is happening here ன்னு பாருங்க. When the spring is attached to the mass will have that gravity. So it will keep going down. So when the mass is going down, right, appo enna agum? The spring is getting elongated. Adanal there will be a restoring force that will come in the spring. spring குள்ள என்ன வரும் restoring force வரும். Okay, so that will be upwards. So restoring force will try to balance the weight of the body, and the restoring force will try to balance, but initially in the restoring force value கம்மியா இருக்கும். Why? Because extension is small, right? Initially அங்க இருந்து நம்ம ரிலீஸ் பண்ணா extension will be small. கொஞ்ச நேரம் கழிச்சு என்ன ஆகும் தெரியுமா? We will come to a situation where the இங்க பாருங்க இப்படி வரும். We will come to a situation where the weight of that body is balanced by that spring force. Weight of the body is exactly balanced by the spring force, but the object anga stop agadu. ஏன் தெரியுமா? Because it is already coming down with some acceleration, right? Means what? It will be gaining some velocity. அங்க initial point ல நம்ம ரிலீஸ் பண்ணா what is it? இதோட velocity எவ்வளவு? Initially what is the velocity? அந்த ஆப்ஜெக்டோட velocity எவ்வளவு? 0 தானா? So நம்ம ரிலீஸ் பண்ணும்போது what is the velocity? 0. அங்கல இருந்து when it is coming down it will be gaining some velocity. கீழ வரும்போது it will be gaining some velocity. So இந்த பாயிண்ட் இருக்கு தெரியுமா? Where the spring force is balancing the weight. Okay, at this point the object will have some velocity, அதனால it will keep going down. So till it reaches another what we call as an extreme point. இப்போ இங்கல இருந்து when it is going down என்ன ஆகும் தெரியுமா? The spring force oda value will be dominating than the weight. இப்போ பாருங்க, இப்போ இங்க வந்து வெச்சுக்கோங்க, the spring oda extension is more now, right? Already அங்கே kx oda value is balancing the weight. When you create more extension means spring force oda value ஜாஸ்தி ஆகும். So net force acting on that object will be upwards. So இது எப்படி தெரியுமா? It's like a retardation concept. It's like a retardation concept. Okay va? So on the point where the spring force is balancing the weight, right? அது என்ன தெரியுமா? That will become what we call as an equilibrium point ன்னு சொல்லுவோம். So இங்க பாருங்க, so நடுவுல இந்த பக்கம் ஒரு எக்ஸ்ட்ரீம் பாயிண்ட் இருக்கும், இந்த பக்கம் ஒரு எக்ஸ்ட்ரீம் பாயிண்ட். ஓகேவா? அந்த பக்கம் ஒரு எக்ஸ்ட்ரீம் பாயிண்ட். நடுவுல what we have is the equilibrium point. Okay, so for oscillations, right, there will be the equilibrium point, and this side will have an extreme, that side will have an extreme. Okay va? So this is the idea of oscillations. இப்படி தான் oscillations நடக்க போறது. So we'll discuss about it when we go to the oscillation chapter. We'll talk about it. But இங்க என்ன தெரியுமா? They are simply asking what is the distance traversed by the object before being stopped. நான் ஒரு ஞாபகம் வெச்சுக்கோங்க, the stopping will happen at the extreme point. எங்க ஸ்டாப் ஆயிடும்? It will be stopping at the extreme point. ஓகேவா? So இப்போ பாருங்க, we are releasing from where? We are releasing from the point where the spring is in the natural state. எங்கல இருந்து நம்ம ரிலீஸ் பண்றது? We are releasing from a point where the spring is in the natural state. Okay, and look at this is an initial state. So initially spring oda potential energy evla 0, kinetic energy of the object evla 0. Enna we are releasing from rest. Okay va? Angle and it is coming down, and reaching this extreme point. If it is reaching this extreme point, okay va? Inga parunga, it is reaching this extreme point. This is stopped again. Means what? Stopped and sonna kinetic energy will 3 0 dana. Kinetic energy will be what? Again it will become 0. What is the spring potential energy? Let us say spring oda extension x nu vechukonga. Spring oda extension evla x. Then spring potential energy evla half kx square. Spring potential energy half kx square. But inga ingonnu energy term varum. Enadi? Gravitational potential energy. Paranga how it comes, because the body of mass m is moving vertically, right? So there will be the gravitational potential energy also involved. So idu eppadi nama tackle pandrathu? If you consider this on the kila bottommost point, right, as the reference, idu nama reference edutha vechukonga. Here the gravitational potential energy of the object evla 0. mass of m, அதோட gravitational potential energy எவ்வளவு 0. ஏன்னா இது நம்ம ரெஃபரன்ஸ் எடுக்கிறோம். ஸ்டார்டிங் பாயிண்ட்ல எவ்வளவு இருக்கும்? because it is at a height x தானா. so starting pointல what is the potential energy, gravitational potential energy value எவ்வளவு? mgx. okay, so இப்ப பாருங்க, we are neglecting air resistance. so அதெல்லாம் நம்ம neglect பண்ணா, other than gravity and spring force, there is no other force term involved. Already both of them are coming in the potential energy term. okay, இப்ப பாருங்க, this is where we have work done by non-conservative forces, other external forces is equal to what? 0. அப்படி இருந்தா we can use what? conservation of mechanical energy principle. அந்த principle நம்ம யூஸ் பண்ணலாம். யூஸ் பண்ணா what is it? initially இங்க பாருங்க, spring potential energy எவ்வளவு? 0 plus kinetic energy of the mass 0 plus அந்த mass ஓட gravitational potential energy எவ்வளவு? mg into x is equal to what? finally, what is the kinetic energy of the mass? 0. spring potential energy எவ்வளவு? half kx square. what is the gravitational potential energy of the mass? 0. ஏன்னா அதுதான் நம்ம ரெஃபரன்ஸ் எடுக்கிறோம். ஓகேவா? ஸோ பாருங்க, mgx is equal to half kx square. இதுல ஒரு x cancel ஆயிடும். so what is it? 2mg by k. அதுதான் x ஓட வேல்யூ. so this is the distance traversed by the object before being stopped. ஓகேவா? so இதுல நம்ம என்ன பண்ணிருக்கோம்? what is it that we are doing? we are looking at the மேல இருந்து அப்படியே நம்ம ரிலீஸ் பண்ணா what is happening? the spring is going to get elongated. but நடுவுல ஒரு equilibrium point வரும். அது பத்தி நம்ம will discuss about it in oscillation chapter. equilibrium point என்ன சொல்லுமா? the force, spring force will balance the weight. that is what we call as equilibrium point. but என்னன்னா அந்த mass அங்க ஸ்டாப் ஆகாது. why? because it is having some velocity. ஏன்னா மேல இருந்து கீழே வரும்போது it is having acceleration downwards, right? அதனால it will be having some velocity. so it will keep going down. அந்த equilibrium pointல வந்து it will go down till it reaches the extreme point ன்னு சொல்லுவோம். okay, so we are applying what? conservation of mechanical energy principle from and the starting point up to the point where again it will stop. that is what we call as the extreme point. the oscillations case la what do we call them as? extreme points. okay va? so what is the answer? 2mg by k. that is what is the distance traversed by the object before being stopped. okay, so நம்ம இந்த problem particularly discuss பண்ணிக்க தெரியுமா? because some people what they do is, okay, there is a spring force acting which is kx and weight. they will look at the equilibrium point condition. but ஏன்னா நம்ம அந்த object release பண்ணா equilibrium point means what? where the spring force balances the weight of the object. and the object, right, equilibrium point la stop ஆகாது. அதுதான basic concept of oscillations. equilibrium வந்து when you go this side or that side, there will be a force acting towards the equilibrium to bring it back. அதனால we'll have what? the tendency to come back to the equilibrium point. so இந்த பக்கம் போன வெச்சுக்கோங்க, then it will have a tendency to come back. same this side also. so that is why the oscillations will be possible. so we'll discuss about it when we go to oscillations. oscillations la what is the main condition? there should be always what we call as a force that will try to bring the object back to the equilibrium. so equilibrium when it is going away, right, there will be always a net force acting which will try to bring it back to the equilibrium. okay va? so we are applying the conservation of mechanical energy from the initial point to the final stopping point. okay, so another question பாருங்க. a block of mass n is moving on a smooth horizontal floor with a constant velocity v0, collides with a light spring of stiffness constant k which is rigidly fixed horizontally with the vertical wall. find the maximum compression in the spring. என்ன நம்ம calculate பண்ணனும்? we should find what is the maximum compression. இப்போ பாருங்க இந்த situation எப்படி இருக்குன்னு சொல்லிட்டு, so we are having a spring of stiffness k, there is a block m, அதோட velocity எவ்வளவு? v0. it is coming and colliding அதுக்கப்புறம் what is going to happen பாருங்க. So there is a block, இப்படி வந்துட்டு it is colliding with the spring, so it will start compressing the spring. அதுதானா? So இப்படியே it will start compressing the spring. என்ன கேக்குறாங்க? Find the maximum compression in the spring. It's a standard question. Okay, standard result. Okay, so என்ன calculate பண்ணனும்? We should calculate what is the maximum compression in the spring. பாருங்க என்ன ஆகும்? When the spring is getting compressed, right, the spring will gain potential energy. Okay va? When spring compress ஆகும்போது it will gain potential energy, but the object will be losing its kinetic energy. The object it will be losing its kinetic energy. Maximum compression ன்னு சொன்னா என்னது? The block is able to compress அதுக்கு மேல compress பண்ண முடியல, அதுதான், that is what we call as the maximum compression, right? So when we have maximum compression, this block is going to come to rest, because if it is having some velocity means it will keep compressing it. அதுக்கு மேல compress பண்ண முடியலன்னா what is it? The block is coming to rest. இப்போ பாருங்க, when you look at this block and the spring together, நீங்க ரெண்டு ஒரே எடுத்து பாருங்க, what is it? Here we will have the normal reaction acting on the block, but here the block is moving along the contact surface, so adanaala work done by the normal reaction evlo 0. Work done by the normal reaction evlo 0. ingu enna, there is no vertical movement kadiyadu, it is the horizontal surface, right? Adanaala and the gravitational potential energy term involve agadu. There is no involvement of the gravitational potential energy. Here what they are saying, it is a smooth. Okay, so even if they are not saying it is smooth, right, friction patti mention pannalanna we have to consider it is what? Frictionless. Whenever they have to talk about friction, right, they should give us what? And the coefficient of friction kudukanum. Kudukalanna what is the assumption we will take? We will take it is what? Frictionless. Okay, so initial state enna theriyuma? This is the initial state when the block is just colliding that spring. Paranga, so ipo enna agum? Since work done by the non-conservative forces and other external forces is what? 0. What we'll have? The conservation of energy, mechanical energy principle inga applicable agum. Conservation of mechanical energy and sonna, here we are looking at the kinetic energy of the mass and spring oda potential energy. Idhil enna theriyuma? Gravitational potential energy term involve agadu. Why? Because the movement is along the horizontal surface, right? We will take this as the reference line. So epo paathalume the gravitational potential energy will be what? 0. Why? Because we are on the reference line only. Okay, so inga paranga, initially is what? When the block is just colliding the spring. So appo kinetic energy of the block evlo paranga? Half m into v naught square. Spring oda potential energy enna? 0. And a spring will be in the natural state dana. Final state idanadi, that maximum compression state. Final state enna menna irukum? We are taking that maximum compression state. Anga paranga, we are saying this will come to rest dana. The block oda velocity will be 0. So kinetic energy evlo? 0. Spring potential energy oda formula enna? Half kx square dana. This x is our maximum compression value. Here x enadi, that is our maximum compression. Okay, so all of that we have to apply what? Conservation of mechanical energy. So initially kinetic energy plus potential energy anyway 0. So kinetic energy evlo? Half m v naught square is equal to final state la irukra kinetic energy plus potential energy. Inga enadi? Kinetic energy 0. So verum potential energy term mattum varum. Half cancel aidum. So paranga, m v naught square by k is equal to x square. Appo x oda value enadai? Root of m v naught square by k. Adha, this is our maximum compression. Idanadi, this is our maximum compression. What is the concept that is involved? Once it is touching that spring, it will start compressing it. இதுல dissipative forces, non-conservative forces அது ஒன்றும் கிடையாது. So we have work done by the non-conservative forces and other external forces எவ்வளவு 0, which means we can use the conservation of mechanical energy principle. But இதுல என்னன்னா gravitational potential energy term வராது. Why? Because we are on that reference line that we are moving. Okay, so initially also it will be 0, finally also it will be 0. So again varum verum the kinetic energy of that object and the spring potential energy in the rendu term da varum. Okay va. அடுத்த question பாருங்க. I think this is a question that has come in one of the previous years. A block mass m moving on the frictionless horizontal surface collides with a spring of spring constant k. Okay va. And compresses it by a length L. The collide பண்ணதுக்கு அப்புறம் it is compressing it by a length எவ்வளவு L. The maximum momentum of the block after the collision. என்ன கேக்குறாங்க? After the collision and the block ஓட maximum momentum. நீங்க சொல்லுங்க when the momentum of the block will be maximum, because momentum என்னது mass into velocity தானா. Momentum means what? Mass into velocity. So எப்போ momentum maximum இருக்கும்? When the velocity of the block is maximum. அப்பதானா. So when the momentum will be maximum, when the velocity of the block is maximum. இப்போ நம்ம என்ன பண்ணணும்? We should calculate when the velocity of the block will be maximum. இங்க பாருங்க, when it is just coming and touching it, the initial point ன்னு சொல்லலாம். Okay, அதுக்கப்புறம் it will keep compressing it. இதுக்கு முன்னாடி நம்ம பார்த்த மாதிரி it will come to the maximum compression. ஓகேவா? அந்த maximum compression ஓட வேல்யூ தான் அவங்க L ன்னு சொல்றாங்க. maximum compression என்னது L. See, initially it is just coming and colliding. அதுக்கப்புறம் it will start compressing. When the spring is compressed, என்ன ஆகும்? The spring energy increases, kinetic energy of the block என்ன ஆகும்? Decreases. அப்படிதானா? So it will keep slowing down. Finally on the maximum compression state ல என்ன ஆகும்? It will come to rest. Okay, so which means we are looking at where the velocity will be maximum. So velocity will be maximum when? At the time of collision. The first point இருக்கு தெரியுமா? அந்த touch point, அங்கதான் velocity maximum இருக்கும். Which means that is where we will have the momentum also maximum. புரியுதா? When the velocity will be maximum, that is where the momentum is maximum. When it will be maximum at the starting point where the block is just touching the spring. இப்போ என்ன தெரியுமா? As it is what நம்ம இதுக்கு முன்னாடி இருக்கிற ப்ராப்ளம் என்ன பண்ணிருக்கோம்? We are looking at, so பாருங்க, normal reaction அதோட work will be 0. ஏன்னா normal reaction is upwards. The motion is along the horizontal surface. அதனால work is 0. Friction கிடையாது. Which means what? Work done by the non-conservative forces and other external forces எவ்வளவு 0. Which means we can apply conservation of mechanical energy principle. Same நம்ம இதுக்கு முன்னாடி பார்த்த ப்ராப்ளம் மாதிரி தான், பட் இங்க என்ன டிஃபரெண்ட் டேர்ம் நம்ம கால்குலேட் பண்ணணும், அவ்வளவுதான். இங்க பாருங்க, when it is touching that spring, let us say v is the velocity. எனவே v is the velocity of the block when it touches the spring. அதோட வேல்யூ நமக்கு தெரியாது, அதுதான் நம்ம கால்குலேட் பண்ணணும். ஓகேவா? சோ இப்போ பாருங்க, that is the initial state, right? Then the point where it is touching is the initial state. Spring potential energy எவ்வளவு? 0. ஏன்னா spring is a natural state. Kinetic energy எவ்வளவு? half m into இதுல capital M நம்ம யூஸ் பண்ணணும். What is the m we have to use? Capital M. ஏன்னா அவங்க என்ன whatever they are giving you have to use the same thing, right? What is the mass of the block? Capital M. So half into capital M into v square. Okay va? So final state என்ன ஆகும் பாருங்க, the kinetic energy of the block will be 0 dana, because it is the maximum compression. Maximum compression value எவ்வளவு? capital L, which means final spring potential energy எவ்வளவு? half into k into capital L square. ஏன்னா அவங்க கொடுத்திருக்காங்க, they are giving us what is the maximum compression in that spring. They are saying the block is colliding with the spring and then compressing it by a length L. Okay, so இப்ப பாருங்க what is it, conservation of mechanical energy தானா. so which means initially whatever the kinetic energy and potential energy is equal to finally இங்க ஒரு half of cancel ஆயிடும். okay, so half cancel பண்ணா அதுல இருந்து v வரும் what is it, v square is equal to kl square by m. okay, அதுல இருந்து v will be equal to what, root of kl square by m. that is the velocity. this is actually the maximum velocity. இதுக்கான corresponding momentum எவ்வளவு, அதுதான maximum momentum. so maximum momentum எவ்வளவு வரும் பாருங்க, maximum momentum எவ்வளவு, mass into the maximum velocity. okay, so இத இருந்து பாருங்க. so numerator we are having so அப்படியே அந்த m நீங்க உள்ள எடுத்துட்டு வந்தா what is it, m square ஆயிடும், m square kl square by m. so ஒரு m cancel பண்ணா l square நம்ம வெளிய எடுத்து போலாம், ரூட்க்கு வெளிய எடுத்து போனா it will be what, l. so root mk உள்ள இருக்கும், l is outside. so பாருங்க what is the answer, the maximum momentum எவ்வளவு, root mk by l, sorry root mk into l. so எப்போ வரும் அந்த maximum momentum, at the time of collision. ஏன்னா இந்த collide பண்ணதுக்கு அப்புறம் the spring is going to get compressed. so spring ஓட potential energy increases and the block kinetic energy will keep decreasing. okay, see இங்க என்னன்னா we are trying to solve the problems in detailed approach. so once நீங்க அந்த கான்செப்ட் புரிஞ்சு வச்சுக்கோங்க, then you know you will be able to easily, so just write the expressions and அப்படியே நீங்க solve பண்ணி போலாம். so you don't need to really ஏன்னா நீங்க solve பண்ணும்போது you will not be writing all these things, right? so since we are writing down all the statements, we are taking some time to solve the question. so practice panna you will start getting the speed. okay, so then this is another type of question. inga parunga, this is a different one. idhil enna, we are seeing a block which is coming from some height. figure given below shows smooth curved track. smooth and sonna what is it, friction kadayadu. smooth and sonna what is it, frictionless. the figure la there is a smooth curved track in a smooth horizontal part. okay, a spring of spring constant 400 newton per meter inga irukka is attached to one end to the wedge fixed rigidly with the horizontal part. enga irukka and the horizontal part ku mela irukka spring irukka horizontal part mela. this is the curved part. okay va, a 40 gram mass released from rest at a height of 4.9 meter. enga and we are releasing it from the height of 4.9 meter. okay va, on the curved part. so enga and anga mela we are releasing it. find the maximum compression the spring. enna nam calculate pannom, we should calculate what is the maximum compression the spring. okay va, we should calculate what is the maximum compression the spring. inga enna theriyuma, we can look at this, friction kadayadu. normal reaction acting on that object will be always perpendicular to the displacement. enna whenever an object is moving along the contact surface, அது horizontal surface இருக்கலாம், or it can be vertical, or it can be curved surface also. when the object is moving along the curved surface, work done by the normal reaction equal to 0. so which means here we don't have any work done by non-conservative forces and other enna sollala external forces, other work kadiyadu. which means what, we can use our conservation of mechanical energy principle. enna use பண்ணலாம், we can use the conservation of mechanical energy principle. இங்க என்ன தெரியுமா, initial state என்னது, the state where we have spring in the natural state, initial spring is in the natural state, the block is at this 4.9 meter height, block is at rest, right? It is released from rest. So initial kinetic energy, initially paranga, initial kinetic energy of the block evla 0, okay va. Gravitational potential energy irukum for the block, it is at a height inga paranga. So we will take this horizontal as a reference, idu nama reference edutha. What is the height? 4.9 meters. What is the height? 4.9 meters, right? Which means what? The gravitational potential energy will be object mass and 40 grams, right? So 40 into 10 power minus 3 ena nama kg ah convert pannom into g. G oda value enna edukalam, because here they are saying 4.9 meters, right? So we will take the g as what? 9.8. okay, so take g as what? 9.8 into height evala 4.9. so this is what? This is the initial gravitational potential energy engade when the block is at the top. Initially spring oda potential energy evala, because spring is in the natural state, right? So initial state ennu sonnanadi the time where we are releasing the block from the top, adha nammaloda initial state, okay va. So adu mudinjது. Next look at the final state. Final state means what? inga nama enna calculate pananum? The maximum compression of the spring. So அப்படியே இது கீழ வரும், வந்துட்டு it will start compressing it, okay. So maximum compressed state ninga paatha, what you will have? The block would have come to rest, திருப்பி it will come to rest, right? Which means what? Kinetic energy of the block evala 0. Spring potential energy will be what? Half into k, 400 into x square. In the x da nama calculate pannom. Gravitational potential energy of the block evala, because the block is coming on the horizontal, adha nammaloda reference. So gravitational potential energy evala 0. புரியுதா? So initial state is the state where we are just releasing the block, மேல இருந்து நம்ம ரிலீஸ் பண்ண போற டைம். So அப்ப என்ன? The block will have gravitational potential energy, kinetic energy of the block 0. இங்க கீழ ஸ்ப்ரிங் இருக்கா, ஸ்ப்ரிங் ஓட potential energy எவ்வளவு 0 initially. So அங்கல இருந்து நம்ம ரிலீஸ் பண்ணா the block will keep coming down along the curved surface, வந்துட்டு it will hit the spring, அதுக்கு அப்புறம் it will start compressing it. So we are looking at the maximum compressed state. அங்க என்ன? The block would have again come to rest, so kinetic energy எவ்வளவு 0, okay. Then the gravitational potential energy of the block will be 0, ஏன்னா it is on the reference line now. வெறும் spring potential energy will be there, அதோட வேல்யூ என்ன? half kx square, okay வா. So penna conservation of mechanical energy principle dana. What is it? Initially the total mechanical energy oda value, which is what? Idu mattum dana. So 40 into 10 power minus 3 into 9.8 into 4.9, adana, that is equal to what? Finally what is it? Half into 400 into x square. So if x value will be in terms of SI unit, and now we have taken everything in terms of SI unit, right? So x will be coming in terms of meters, x will be coming in terms of the meters, okay va. So paranga, what will be the answer for this x value? In the x da nama calculate pananum. enagum 2 1s are 2 200s are. So 200 நம்ம இப்படியே இந்த left side எடுத்துட்டு போலாம். So 40 into 10 power minus 3 into 9.8 into 4.9 by 200, அதுதான் x square. So நமக்கு என்ன வேணும்? x வேணும், which means root of that. Root of 40 into 10 power minus 3 into 9.8 into 4.9 by 200. இங்க பாருங்க. So இதில now we can try to take some things common out. So we can just divide this by 2. So 20 2s are 40 and 200s are 200, okay va. So ipo parunga, we have inga 20 irukka, denominator 10 power 2. So neenga adjust panna enna varum? This 2 can be multiplied with 4.9, it becomes what? 9.8. So parunga, so 2 multiplied with by 4.9 is what? 9.8. So we'll have 9.8 square. அந்த மாதிரி there is a 10 power minus 3 into 10, அது என்னது 10 power minus 2. denominator 3p we have a 10 power 2, which is what? Totally 10 power minus 4 item. Okay va? So this is the number of x value. So what is x value? Root of 9 point square into 10 power minus 4. Just mathematical simplification. Okay va? So what is the final answer? Apdiye root la irundhu and 9.8 veliye varum. What is root of 10 power minus 4 means 10 power minus 2 dana. So what you will have? 9.8 into 10 power minus 2 meters, which is what? 0.098 meter. Okay va? 0.098 meter. We can say 9.8 in 10 power minus 2 meter means we can also say 9.8 centimeter. Appadi solala. Depends upon what is the option given to us. Okay. So option they are giving in terms of meters means meter edukano. If they are giving in terms of centimeters means we will take it as centimeter. Okay va? So இப்படி தான் இந்த problem approach பண்ணணும். இதில் என்ன we are having initially the block is at the top, it will have potential energy, kinetic energy irukadu, spring is in the natural state. When you look at the maximum compressed state, anga enadhu the potential energy of that block, gravitational potential energy will be 0 and it is coming on the reference line. Kinetic energy irukadu. Why? Because it is in the maximum compressed state and sonna the block would have come to rest. Okay, and the spring is compressed, so it will have a potential energy. Okay va? So what is the maximum compression value? 9.8 centimeter. Evlo varum? 9.8 centimeter. Okay va? So adutha parunga, this is an interesting question. A ball of mass 9 kg is dropped onto the vertical spring. Inga parunga. So 9 kg ball edutittu we are dropping on the vertical spring. Okay. Now parunga, what is the initial length of the spring? Evla? 9 meter. And the spring or the spring constant 320 Newton per meter. The block compresses the spring by what? 1.7 meter. Block enna pandrathu? It is compressing the spring by what? 1.7 meter. Okay va? Calculate the energy loss. What they are saying? Calculate the energy loss. Energy loss and sonna, here what they are basically asking is initially your total mechanical energy இருக்கும். இதெல்லாம் தெரியுமா? We will have to consider the potential energy. The ball is moving in the vertical line, so it will have a gravitational potential energy. Okay va? And the madri we have to see whether there will be kinetic energy or not. Kinetic energy irukum, but the thing is initially this is dropped from rest. Okay va? Finally in the maximum compressed state, the block will again come to rest. Initially நம்ம என்ன பண்ணிருக்கோம்? We are dropping it. அப்படி நம்ம drop பண்ணா the initial velocity எவ்வளவு? 0. So அந்த initial positionல kinetic energy இருக்காது. When it is coming down, it will gain kinetic energy. அந்த collide பண்ணதுக்கு அப்புறம் it will start compressing the spring. It will start compressing the spring. So it will compress the spring, and in the maximum compression state, the ball is compressing the spring by what? 1.7 meter. இங்க பாருங்க, initial spring length எவ்வளவு? 9 meter. Compressed by 1.7. Adhanala it is becoming what? 7.3. Okay va? So in this compressed state, ingeyum appadida, the velocity of the ball will be 0. Okay, so here the energy terms involved are what? The gravitational potential energy of the ball, rendavathu the spring potential energy. Okay, so we look at what is the initial total mechanical energy, and the madri we will also look at what is the final total mechanical energy. Okay va? So inga enna agona, we will see that the initial total mechanical energy will be higher than the final total mechanical energy. And some of the energy could be lost because of the collision. Oh, and the ball collide agumbodhu what will happen? Some energy might be lost in the form of heat or sound or light. Okay, so that energy loss is what they are asking. Pakala, what is it? So the thing is, when we look at the initial state of that ball, it is at a height of 15 meters from the surface. Is that number of reference? The reference length, what is the height of it? 15 meters. So initial gravitational potential energy M is what? 9 into G எவ்வளவு எடுக்கலாம்? We can take it as what? 10 into height another 15. Okay va? So this is what? The initial gravitational potential energy. இது நம்ம calculate பண்ணலாம். What is it? This is 9 15s are what? 135 தானா? So 1350 joules. ஏன்னா everything is in the SS system. இங்க எவ்வளவு? 9 kg 15 meter. G10, everything is the SS system. Okay va? That is the initial gravitational potential energy. Initial spring potential energy எவ்வளவு? That is the natural state of the spring, right? So we'll take it as 0. Initially spring is in the natural state, so we'll take it as what? 0. Okay va? அப்புறம் பாருங்க, the final gravitational potential energy எவ்வளவு? Finally when the ball is compressing the spring, பாருங்க, the final height எவ்வளவு? What is the height of the ball from the surface? Reference இருந்து இது என்னது? 7.3 meters. What is the height of the ball from the reference? It is 7.3 meters. So 9 into 10 into 7.3. Okay va? So இது என்ன வரும்? 9 into 73. What is 9 into 73? 657 வரும். What is this? 657 joules. Okay va? So this is the this is the final gravitational potential energy. What is the final spring potential energy? இங்க பாருங்க, the compression is what? 1.7 meter. Spring constant எவ்வளவு? 320. So half into 320 into compression square 1.7 square. இதுல என்னன்னா we have to just do some calculate பண்ணணும் அவ்வளவுதான். So 2 ones are 2 160s. So இப்போ இந்த term மட்டும் நம்ம simplify பண்ணணும். What is it? 160 into 1.7 the square. So 1.7 into 1.7 எவ்வளவு? 7 7s are 49. So if you remember the squares of some common numbers means it will be easy. Okay, இல்லனா you can still do it. 7 ones are 7, so 119. Then we'll have 7 வரும் 2.89. What is 17 square? 289 தானா? 16 square 256. Okay, so 1.7 to 1.7 2.89. So 2.89 into எங்க என்ன வரும்? 160 வரும். 2.89 into 160. Okay, இது நம்ம approximate பண்ணி எடுக்கலாம், இல்லனா we can just take it with the as usual. Okay, இது என்ன தெரியுமா? 160 means we can say 16 into 10. அப்படி நம்ம எழுதலாம். 160 பதிலா we can write as 16 into 10. So it will be what? 28.9 into 16. 28.9 into 16. இது நம்ம multiply பண்ணலாம். Multiply பண்ணா we'll get what? The final spring potential energy வரும். இது நம்ம multiply பண்ணா என்ன வரும்? Final spring potential energy வரும். So படி பாருங்க, 16 9s are what? 16 9s எவ்வளவு? 144 தானா? So இங்க 4 வரும், 14 அப்படியே வெச்சுக்கோங்க. 16 8s. What is 16 8s? 128 ah? What is 16 8s? 128, right? So 128 நீங்க ஆட் பண்ணா என்ன வருது? 142. So 2 இங்க போய்டும், திருப்பி 14. அப்புறம் 16 joules are what? 32. ஆட் பண்ணா what is it? 46. Okay, so என்ன வருது? 462.4. So 28.9 into 16 எவ்வளவு? 462.4. So இதுதான் final spring potential energy. Okay வா? So இப்போ என்ன பண்ணணும் பாருங்க, we are having the initial gravitational potential energy and initial spring. Initial spring எவ்வளவு? 0. So total initial mechanical energy எவ்வளவு? இதுதான் 1350 joules. Total final mechanical energy பாருங்க எவ்வளவு பாருங்க? 657 joules. Okay வா? Plus this 462.4 joules. 657 plus 462.4. Okay, so that's it. So what is the energy loss means? Initial mechanical energy minus final mechanical energy. This is taking us some time to calculate. Sometimes we can get some questions like this also, which will be little bit more time taking. Okay, so these kind of questions we have to keep it till the end. So you see question like this, right? You have to keep these kind of questions till the very end of the paper. Okay, so paranga 657 plus 462.4 idanade 9 1119.4 joules. So 1350 landu we have to subtract this amount, right? Ena initial landu we have to subtract the final 1119.4 நம்ம subtract பண்ணனும். subtract பண்ண என்ன வரும் நமக்கு? What we will get பாருங்க, this is what, இங்க ஒரு 6 வரும், then we'll have இங்க என்னது 0, okay, then we'll have 3, அதுக்கப்புறம் we'll have what, 2, so எவ்வளவு 230.6 joules. This is what the energy loss. Check பண்ணுங்க, what should be the answer we should get? 230.6 வரணும். So இதுல என்ன இருக்கா, கான்செப்ட் சிம்பிள் தான், பட் ஒரே சேலஞ்ச் என்னன்னா it is taking lot of calculation steps. So if they are giving us some on the simplified இப்போ 1.7 அப்படி இல்லாம they are giving us like proper numbers 2 3 அப்படி கொடுத்தா வெச்சுக்கோங்க, then it will be easy for us. இங்க வர பிரச்சனை என்னன்னா we are having some irregular numbers. So அதனால when we are doing the squares அதெல்லாம் calculation பண்ணும்போது we are taking some time. But if they are giving us rounded off numbers like the ball is compressed in the spring by 4 meters அப்படி கொடுத்தா it would have taken lesser time to calculate all these things. ஓகேவா? பட் இதுல procedure நம்ம தெரியணும். What is it? In this kind of model, right? என்ன பாருங்க, we are dropping an object from the top. அங்கல இருந்து நம்ம drop பண்ணா it will move down, it will hit the spring and the spring is going to be compressed. இதுல என்ன தெரியுமா, when they are asking us இந்த மாதிரி questions like the energy loss அப்படி கேட்டா we are looking at what initial position is what when you are dropping that ball. அந்த மாதிரி final position என்ன, when the ball is doing the spring maximum compression. Okay va? So that is about these kind of questions. Okay, we'll continue our discussion in the next class. Like spring we have to discuss couple of more things about the spring related problems. See, we are trying to do different models of questions on each segment so that you get familiarity. Idhu enna theriyuma, the main thing is when you look at a question in physics, paatha odane you should not be thinking okay how do I approach. You should always see some familiarity. Oh, idu enga nam paatha madiri iruka. So when you get that familiarity, right, remember that is the indicator that you are on the right track to crack physics need part. So problem பார்த்துட்டு you are thinking oh இது எப்படி approach பண்ணனும், அந்த மாதிரி situationல if you are going into the final examination means that is not the right situation to be. So every problem you see, right, we should get some familiarity. Okay, இந்த மாதிரி if not the same model you should have some kind of familiarity. Oh இத நான் எங்கயோ பார்த்த மாதிரி இருக்கா, that kind of as a mindset you should get into. Then that will give us the confidence to solve the problems in more என்ன சொல்றது, with more confident approach. Okay va? So keep solving, practicing questions. Past year need questions paranga, past year aims questions paranga. Okay, if you are having any doubts you can just check with me. Okay guys, we'll see in the next session.